Hello everyone, welcome to this video where we are given this diagram of a cross section of a tunnel. And they also let us know that this OATB is a sector of a circle centered at O, radius is 5. And there's a right angle triangle OAB. Find the area of this cross section. So if I may zoom in, right? Then I can straight away see that since O is the center, OB and OA is radius. So I can actually find the black color area very easily since there is a right angle triangle. So I can easily apply half time base times height. The next area that I would like to then see would be this. I'm going to color it out. So the red color sector area, how do I find it? Of course, I will then need this angle here, which is 270 degrees. And with that angle and the radius as 5, I can find this area easily. And after which, what do I do to both area? The red and the black? Yes, we add them up. Okay, clear about how we solve for the area. And once I know that, then I will be able to share with you that, yes, I will have my 270 degrees and find the area of the sector using the formula. Angle at the center divided by 360 followed by multiplication of the pi r square. And notice Mr. Tan here did not give my answer to many significant figures. Rather, I leave in terms of pi because this is not the final answer. Area of the triangle is half time base time height, 12.5. So all we have to do to find the whole area of the cross section, I just need to add my red color area with my black color area to give me 71.4 meters square to 3SF. So that is for part A. Part B then require us to find the length of AB, which since we are looking at this right angle triangle, I would just need to apply my Pythagoras theorem. Yeah, so this is pretty straightforward. After which, find the perpendicular distance from the point T to AB. Okay, so now we are looking at going to just cut this out to use for my part C answer so that we can just focus on this. So right, what it is trying to say is that I'm going to, from point T, give a ruler, I'm going to then have this line that is perpendicular to AB. And how do I find this? Well, first of all, do take note, T to O is also a radius, so this one will be my R5. So my job now then is to find this. Okay, and we can do that easily. How? I'm actually dividing this isosceles triangle, since both sides is 5 and 5, into 2. And you will start to see that Mr. Tan actually knows that OAB, this is actually 45 degrees. Why? because this is a right angle and also isosceles triangle. So this is also 45 degree. And if I were to draw this triangle out, O, A, this is 45 degrees. I have my 5, and this is the green color length that I do not know. But I do know this is the right angle. Then applying tuakaso with respect to this 45 degree, I will have my hypo. This is my opposite. And with tuakaso, O and H, you will then see Mr. Tan applying and getting the sine using the sine ratio. Okay, this is my height of O above AB, which is the green color portion. Then all we have to do is to add 5 to it to get the final answer of, with the radius 5. This is the green color length of O above AB. That will give me the final answer of 8.54 meter. With that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.